My name is Ariel. I'm a software engineer from Israel, Tel Aviv. I work in the industry over 22 years now. Worked in various companies, Bezeq, Telecom, CloudLock, Cloud Security, Cisco, and now I'm head of engineering in LinearB. LinearB is a small startup that helps dev teams to improve by analyzing their Git data and Jira data, giving visibility about their quality, the iteration progress, and the development pipeline. And over the years, I encountered with a few types of developer, I would call. The happy and the sad developer. The happy developer knows that he has impact about the business, pushing value continuously, probably with a high quality, which means a nice coverage of tests, either unit or integration test. There is a CI, CD in place, everything is smoothly in the pipeline, and eventually low level of production issues. The sad one, on the other hand, feel no impact because they spend all their times on bugs, customer issues. Usually those companies has no CI, CD, so they are manually deploying their stuff sometimes. Sad. So we do want a happy developer. We don't want sad because they will leave. So how do we get that? So we need to talk about DORA metrics. DORA stands for DevOps Research and Assessment. Anyone is familiar with DORA? Oh, nice. Okay. So DORA, it's actually a performance metrics that helps DevOps teams to understand how effectively they develop, deliver, and maintain software. They identify elite, high, medium, and low performing teams and provide some baseline to help organizations continuously improve. DORA metrics defined by organization named Google DevOps Research and Assessment, and their outcome based on 6 years of analyzing 30,000 engineers. And we can break down DORA into two main categories: speed and stability. DORA metrics include 4 performance metrics, and by comparing all 4 of them, one can evaluate how well organization balance between those two, the speed and stability, how fast a dev team delivers new stuff out to production, and how stable the system during this process and out of the process. So let's dive in and see what those metrics one by one. So first one is the cycle time, also known as lead time for changes, LTC. Cycle time measures the time it took from the first commit until it went out to production. This metric is one of the important one that DORA defined. It tells you how agile the team is. It is not telling you how long it takes to implement the change, but how responsive the team is also for the demands and needs of the business. Cycle time can reveal symptoms of poor DevOps practices. If it takes weeks or months to deploy something or release into the production, it may probably because lack of continuous integration, CI, or continuous deployment. So DORA identified this cycle time benchmark you can see on the right. Elite performers, cycle time less than 1 hour. We have like 4,000 companies. I can tell you that maybe 5% out of them has this metric, less than an hour. High performers is 1 day to 1 week. More, around 40 or 35% of the customers are releasing in that time. Medium performer, 1 month to 6 months, very sad. And low performance, I don't know if there are any customer that releasing in 6 months today, but this is what DORA said. The second metric, so just before we go to the second metric, we have a screenshot from our product. This is how we present cycle time. we break it down into 4 segments, 4 parts. We are measuring the coding time on the left here. This is the time since the first commit until we issue a PR, pull request. And then we have the pickup time. This is the time since we issue a PR until someone picked it up for review. We have the review time. This is all the back and forth, reviewing, fixes, another commit, and so on. And then we have the deploy time. And all the tests, sanity, smoke test, the builds, and all of that in that part. Second metric, we have deployment frequency, DF. This is how you often ship changes, how you consistent your software delivery is. The best way to enhance DF is to ship a bunch of small changes, which sometimes has a few upsides. If deployment frequency is too high, it might reveal bottlenecks in the development process. The third one, from stability category, is CFR, change failure rate. This is the percentage of releases that result in downtime, degraded service, or rollbacks, which can tell you how effective a team is at implementing a change. As you can see, there's not much distinction between the benchmarks they define, all the elite performers between 0 to 15%, and all the rest around that benchmark. Change failure rate is particularly valuable metric because it can prevent a team from being misled by the total of number of failures they encounter. Teams who aren't implementing many changes will see fewer, but that doesn't necessarily mean they are a success. So this might mislead. The last metric is MTTR, mean time to restore, or mean time to recovery. Some call it like that. Mean time to recovery is the average amount of time it takes your team to restore a service when there is a disruption or an outage. This metric offers a look into the stability of your software, and as well as the agility of the team with challenge of pushing more and more value. So if we can summarize everything, we have these 4 DORA metrics, the speed one on the left, cycle time, deployment frequency. On the right, we have CFR and MTTR. These are the speed and stability. And we do want a healthy process. So above of that, I would like to add another metric that we at LinearB think worth mention, because it's not less important. This is the PR size. So the PR size, small PRs, reduce risk, right? It's less changes, make the team more agile, breaking down features and changes into small chunks. In an analogy of roads and vehicles, more bikes on road will be easier to manage or guide rather than heavy trucks, right? So we have a data science team that took that, and with our database, over 1 million pull requests, and analyzing that, we got to the conclusion that pull requests under 200 lines size get merged twice as fast. So why is that? So obviously, picked up faster because it's small, more attractive pull request. If I'm encountering with a huge pull request, I'm going to push it, do it later, and of course, reviewed quickly. I don't know, 50, 70, 100 lines of codes, it's like a decent PR, and merged faster. So you can see in this chart, 100 code changes will be pushed in average of 2 days, based on this research, and 500 will be pushed in 5 days. It's huge. Also, another implication for that, if you're reducing the PR size, you will get more deployment frequency. Think about production line that your items keep moving with no disruption at all. Remember that larger PRs that got stuck in your pipeline, finding the root cause of those PRs are harder than small PRs with small changes. This is also from our product, 2 screenshots. One is a huge PR of 190 change. Oh, sorry. Okay. So you can see here, this is the pickup and review time for this PR. It took over 3.5 days just to pick it up and then review it. The second one, 21 code changes. I know it's not all the PRs in this size, but see the difference. It's like 1 day totally. So I can tell you that when we start measuring that, this is happening by itself. The pipeline is being better, and you find out your dev team will improve by itself. Teams in my organization shows their DORA metrics every end of iteration, and there is some competitive thing, and this is how you get the happy developers. Yeah. So with that, I don't know if you guys went to the previous talk of my colleague yesterday, but he talked about that a bit with continuous merge. So if you don't, I will wrap it up in a minute. So there is a CI/CD, right? Continuous integration, continuous deployment for that part. And now we really think there should be a continuous merge as well, because we do think there's some processes over here that we can automate, right? So how do we do that? Few things. First of all, as I said, you need your PR to be more attractive. How do you do that? You enrich them. You add some context. For instance, estimated review time. How much lines of code you're going to encounter, and so on. Fast lane PR. So we have a bot that push notification about each PR when you assign someone. So you can, if it's like a 2, 3, 4 lines of code, you can approve the PR in the Slack notification. I will show you in a minute a screenshot of that. And automate merge. This is something we are working on right now. You will be able to define rules with PRs that has, I don't know, like a few, like if you change like an MD file or just the JSON, configuration JSON. So you can make it like approved by itself automatically, because there's no risk pushing that. So why someone should pick it up? So here you can see, first of all, the attractive PRs that I show you. This is how it looks. And here you can see the estimated time to review. So you know when you get this notification that you have like a couple minutes here. So then you can go to the to this PR and just review it. And on the right, you can see the inline approve notification that I just mentioned. You can see here, this is the notification with the snapshot, with the screenshot of the diff itself inside the notification. And here you can add your approval comment and hit approve, and that's it, done. So, really nice, no? Okay, so Git stream, this is a new product that we are working on. This is the automation that I just mentioned. You will be able to define rules, as I said, based on file types, based on time in day, based on the specific files. If you would like a review process of someone, if someone touched these risky files, put me as a reviewer. If someone touched the other part of the repository, put like, I don't know, someone else, and so on. We have different types of rules that we're gonna come with, and you can register to the early beta that we are releasing in a couple weeks. And that's it. Thank you very much. If you have questions.